Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mikaella. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
All right, nicely done. Thanks for taking care of that, Mikaella. Now I don't have to take care of that. So where do you go to school?
Ronald Reagan.
And what grade are you in?
6.
How is sixth grade?
Good.
What is the best thing about sixth grade?
Probably when we went on field trip to Camp Keep.
Oh, okay. So you already, did you just do that? And that was that last week?
Mm-hmm.
All right. So what was one of the best things about going to Camp Keep?
I think it was like the tide pools.
The tide pools. All right. So is that where are you guys walking around there, or is that when you're on the docks and you're kind of reaching down for things?
Yeah, kind of like reaching out.
Okay. And do you remember any of the things you guys were able to kind of see, or?
It was like hermit crabs and sea urchins.
Okay. And had you seen those before, or was that first time?
First time.
First time. All right, cool. So how was it staying away from home for a whole week?
It was nice.
Okay, so it was nice. All right. Do you have any brothers or sisters that you normally deal with at home?
I have a younger sister.
Okay. So was it all right getting away from your younger sister for a little while? Yeah, there you go. All right. So what did you think about the food at Camp Keep?
It was good.
Yeah, okay, so you liked it? Because I always hear kids talk about the food at Camp Keep, and they always go on and on and on about how great it was. Did you have a favorite meal over there?
Not really.
No, but it was all good, it was all right. So were there any field trip, like I know that whole thing was a field trip, but different day trips? And I know you like the tide pools. So did you find anything that you would be like, I want to go do that again? You know, like with your family or some other time? Which one?
Like the whole thing, basically.
Okay, so you like the whole thing. Good. Well, you know what? When you get a little bit older, I think you have an opportunity where you could possibly be a counselor and you're able to go with another school and kind of help them out. Is that something you might want to do? All right, cool. Well, you know what you're going to do right now? You're going to help out me do the social media problem of the day. You ready? All right, let's take a look at it together. All right, so we have 3 plus 2, and those are in parentheses, and then we have a 2 minus 7. So first of all, when you see that, what is the first thing you notice or the first thing you want to take a look at?
The parentheses.
All right, so the parentheses. So we know 3 plus 2 is in parentheses. So that's obviously 5. But what about that 2 on top? What is that?
Well, normally a math question, I'll see it's like the power number.
Right, it's a power, right? So it's whatever's in the parentheses raised to the second power. And do you know what that means if it's raised to the second power to the power of 2?
Like you add, like 0.
So an exponent, right? So if I said 3 squared, right? 3 with the exponent 2 on top, that would mean 3 times 3, right? So 3 squared would be 9. What if I had 2 squared?
4.
That would be 4, right? So what about if I had 4 squared?
4 squared, 2.
4 squared, because that means 4 to the second power. That's 4 times 4.
16.
16. So here we've got 5 squared. So what would 5 squared be?
2.
So 5 to the second power, right. So 5 times 5 is?
25.
25. So now we have 25 minus 7.
17.
And which one do you think it is? A, B, C, or D? So we have 25, we're going to take away 7. So let's go 25, 24, 23,
18?
18. So you think it's D, 18? All right. Now, do any of those answers up there look like they are totally wrong? Like there's no way one of those answers would not fit?
Like A.
Why do you think A would not fit?
Because it's like, it's adding, but the subtraction doesn't make sense how it get onto the negative side.
Yeah, so it's saying that we have to end up on the negative side, right? But we're adding something, we're getting a bigger number because of that exponent too. So D is your final answer? All right, let's take a look, see if D is correct. D is the correct answer, nicely done. First problem done, pretty good? All right. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays between 3:30 and 5:30. Time now for today's Math in the News. All right, so this year we know that there's a big election going on, and that's going to be coming up in about 2 weeks. And a lot of the things in the news and on TV, any social media that you look at, it's probably very hard to escape polling. And a lot of times they hear, well, you know, this person is ahead in the poll and this person's here in the poll, and then we have margin of error, and what does that mean? So we decided we take a little bit of a look at this, and election year, what is polling? So a poll makes it possible to gauge public opinion by surveying a relatively small but representative group of people within a given population. The smaller group is known as a sample. So if we have a big population, so let's imagine this is 100,000 people. We can't talk to all 100,000 people in a given time that we need to. So we're going to take a sample of that 100,000 people. So the population is everyone, the sample is part of that population. So we need to have an accurate sample, so that's the next thing. When pulling a sample from a population, the sample must be representative of the entire population, not just a few. So this way we can see the target population. A representative sample shows people from each different parts of the population, where an unrepresentative sample is showing only 2 different parts of the entire population. So you want to get an accurate sample the best you can. Next, we go on to mean, median, mode, something that a lot of kids are already aware of if you're in upper elementary, junior high school especially. So before you go into statistics, which usually takes place during high school and college, you need to know how to sample a population, learn about mean, median, and mode. So the mean is simply the average of the numbers. The median, think about the median in a road, it's in the middle of the road, so the median is the middle number. The mode, just think about MO, most often. So the number that shows up most often. So quickly again, because a lot of kids get confused by it, mean is the average, median, the one in the middle, and mode is the most often. All right, so now what we'll do is we will go ahead and work on one of these problems. So we're going to do mean, median, and mode with all of these. The first thing you want to do is take all of the numbers in the data set and put them in order from least to greatest. So we know that we have a 3 is the smallest, then we have a 4, and I'm just going to underline those so I know I use them. We only have 1, 5, 1, 6, 1, 7, so I'll put a 5, a 6, and a 7. I know I have an 8, and now I have 3 10s. So I need to write down 10 3 different times. Even though it's the same number, we need to represent it as many times as it's listed in the set. So the first thing we can do is the mean, which once again is the average. So if you have a calculator, by all means use that. It's simply a tool to make things easier. But I think we can go ahead and work this in our head. So we've got 10, 20, 30. Here we can make another 10, that's 40, 50, and then 13 makes 63. So we know that the whole thing adds up to 63. Now, one thing I would caution you about is if you're using a calculator, you want to probably do it one more time, because I myself, and I'm sure everybody else has, if you're putting numbers into a calculator quickly, sometimes you might hit the wrong one. So just double check it to make sure that you've got 63. We need the average of the total divided by the number of data set. So we have 9. So we're going to go 63 divided by 9 is going to be equal to 7. So 7 is the mean. Now the median is the number in the middle. So we can see that we have 3 numbers in the beginning here, and we can take 3 numbers off each end. Now we have 3 numbers in the middle, one there and one there, so the number in the middle is 7. So the median is also 7. Now the mode, once again, most often. So we can see this is once, 3 of them. So 10 is going to be the mode. So there we go. That is the mean, median, and mode. Just a little something to get you ready for when you get into a higher level math class such as statistics. That is today's Math in the News. We'll be back with more right after this.
My name is Jillian, and this is a little bit about the Pythagorean Theorem. So this is the equation we use, which is a squared plus b squared equals c squared, which a lot of kids my age would use. So for a, we are going to label this 6 inches. And then for b, we're going to use 8 inches. And so since a is 6, we're going to use 6 times 6 equals 36. So a equals 36 inches. And for b, we're going to use b squared, which is 8 times 8 equals 64. And 36 plus 64 inches would be which would be 100. Now we're going to use the square root of 100, the square root of 100, which would be 10 inches. So C equals 10 inches. My name is Jillian, and that was a little bit about the Pythagorean Theorem.
And there we go, the Pythagorean Theorem, a little something else that you're going to see in junior high school, and if you're lucky, probably in 4th, 5th, or 6th grade also when you start learning about right triangles. In studio with us, we have Mikaella, a 6th grade student from Reagan. You doing well so far? Mm-hmm. All right, I've done all the heavy lifting, so it's time for you to get to work now. You ready?
Yeah.
All right, why don't you go ahead and grab that pen right there. So here it says pentagonal numbers. So before we even get into pentagonal numbers, what I'd like you to do is just simply take a look at the top row and tell me anything that you notice about the top row of numbers.
Well, each number is getting bigger.
Okay, each number is getting bigger, so that's good. How are they getting bigger, do you think? Is there a pattern to them?
Probably keep adding on the dots, making the pyramid bigger and bigger.
Okay, so they're adding dots to make the pyramids bigger, all right? So here, if I went from 1 to 3, how did I do that? What did I do?
By adding 2 more to...
Okay, so I added 2. And I'm going to make this pen a little thinner if possible. All right. So we're adding 2. So now if I go from 3 to 6, what did I do?
You added like 3 more.
Okay. So I added 2, then I added 3. What do you think is going to happen next?
You add 4.
You're going to add 4. Now, does that work? If I go from 6 to 10, does that add 4? It does, right? What do you think is going to happen next?
You add 5.
Okay. And does that actually work where I add 5? Good. What do you think is going to happen next?
It's going to be adding 6.
Right. So put up there, add 6. So here I'll put add 5. You're going to write add 6 up there. And instead of drawing it all out, what would the number at the bottom be?
6.
Because here we have 1, 3, 6, 10. We added 5, got to 15. So now we have 15. We add 6.
6.
So what's good? So here I had 1 and I added 2, so I got 3. So now I have 3, I added 3 and I got 6. 6, I add 4, I get 10. 10, I add 5, I get 15. If I have 15 and I add 6, what's 15 plus 6?
21.
There you go. So put 21 down at the bottom right there. So these are triangular numbers. Does that make sense that they're called triangular numbers? Right? Because they all shape like a triangle. Okay? What do you think these numbers are called?
Triangle, no, like squares.
Square numbers, right? Have you ever heard of square numbers? Yeah, you have, right? So look, this, right, shaped like a square, they're all shaped like a square, right? Because this is a 2 by 2. This is 2 squared. Remember the problem we did earlier, right? So what do you think this is? So this is 2 squared.
And 3 square.
Right, so go ahead and write 3 squared under that one. So to the second power, right? Always to the second, 3 squared, all right? Because 3 times 3 is 9. So what do you think this one is?
4 square.
There you go. So go ahead and label that as 4 squared. Because 4 times 4 is 16, right? So what's 25 going to be?
5 times 5.
5 to the second power, right? 5 squared. So go ahead and write 5 squared up there. There you go, all right? So these triangular numbers, square numbers, right? Because a triangle has how many sides?
3.
3 sides. Squares have how many sides?
4.
4. So now we have pentagonal numbers, okay? So how many sides on a pentagon?
5.
5, all right? Now this one's going to be a little different, okay? You ready? Okay, so here's the formula for pentagonal numbers. Have you ever had to do that yet in 6th grade? It's your lucky day, Mikaella, because here we go. You ready? Okay. So here we can see the first one is 1. Just like in all of them, it's all you have to start with 1, right? Then the first triangular number, right, because we're counting by 3s, is 3. Square numbers, it's 4. The first one here is 5, okay? But now we go, see here we can't go add 2, add 3, add 4, add 5, add 6, add 7. We can keep doing that, right? Here we can go 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and keep on going. Here, if we go from 1 to 5, how did we do that?
You add 4.
Right, we could add 4. Is there anything else we could have done? Instead of adding 4, is there another way to go from 1 to 5? Could we multiply by anything?
And multiply.
Okay, we could multiply by 5, right? Now, if I go from 5 to 12, what do I do?
Add 6.
Well, I could add 7, right? So 5 plus 7 is going to give me 12. But I'm not multiplying by 5 anymore, am I? There's nothing easy that will multiply by 5 to get us 12, is there? So now if I go from 12 to 22,
Add 10.
add 10, right? So I'm adding 4, adding 7, adding 10. But now if I go from 22 to 35, now I'm going to add 13. All right? Do you see a pattern at all? 4, 7, 10, 13.
No.
Okay, so think about this. If I'm starting at 4, right, and I go to 7, I increased by 3. If I go from 7 to 10, how many did I increase?
3.
3. If I go from 10 to 13, how many did I increase?
3.
3. All right, so there's a pattern with all numbers and all mathematics. All we have to do is find those patterns. All right, so what we want to do is we want to find the 4th pentagonal number. All right, so we want to find pentagonal 4. That means the 4th pentagonal number. All right, so this is the first one, the second one, the third one. Do we already know the 4th pentagonal number? What is it?
22.
22. But let's put it into the formula and see if it works. Are you ready? Okay, so n is going to be 4. So go ahead and write a 4 there, and then put an equal sign. And now what we're going to do is we're just going to fill in what goes for these n's. So what is n? We already know what it is. What is it?
4.
4. So put a 4 outside the parentheses. Now what's inside the parentheses up there?
3 and minus 1.
Right. And what does 3n mean? You know what that means when a number and a letter are right next to each other? That means you're going to multiply them. Okay? So if we have 3, what's n again?
Like multiplying.
Right? And what are we multiplying by right now?
Negative 1.
Right. So put 4 there. And we're going to close parentheses, and then we're going to go minus 1, and then we're going to leave the 2, because that's already there. Make sense so far? Because all we're doing is putting the number 4 wherever the letter N is. Okay? So now we're going to go like this. We're going to go 4 times. Now what's 3 times 4?
12.
Okay, and what's 12 minus 1?
11.
All right, so put the 11 in there. Close the parentheses. And we're going to all divide that by what?
2.
So put the 2 down there. So now I want you to do the next part, okay? So what is 4 times 11?
44.
All right, so put the 44 on top. What goes on the bottom?
2.
2. Now, in your head, do you know what 44 divided by 2 is? What is it?
22.
You're pretty slick there, sister. All right, so put down 22. All right, so by figuring out the 4th pentagonal number, by doing it with the formula, you saw that the 4th one was 22. And if you drew it out, we can now prove that the 4th one is 22. Does that make sense? All right, good. You know what? For your great effort today, you've got yourself a ice cream courtesy of Sweet Fix. Do you have a favorite? Do you have a favorite style of ice cream or a favorite flavor?
And like cookies and cream.
Well, when is it?
Cookies and cream.
Cookies and cream? Well, I know that they have cookies and cream at Sweet Fix, so hopefully you have an opportunity to go over there and try some ice cream. You're going to do that? All right, because I'll go with you maybe sometime, all right? We'll be back with more right after this. Simply amazing to look at. You look at those for hours. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. In studio, we have Lucy. How are you today?
I'm great. How are you?
I'm excellent myself. Thank you. Now, you are from Valley Strong Credit Union. And what is your role with the credit union?
I am actually a business banker, so I help small to medium-sized businesses with their lending and cash management needs.
So if I wanted to start a business, I would come to you, or once I have a business, I go talk with you?
Preferably, my target client is an established business that's been in business for a minimum of 2 years.
Okay. And, all right, so we're going to talk about how to start businesses and once you're up and going, some of the things like that. How did you,
Exactly.
first of all, get involved with the credit union?
Well, I've actually been in banking my entire life.
Okay.
Fun fact, I wanted to be a banker since I was about 5 years old.
Why?
You know, that was back in the career teller days when everybody dressed up, and it was just the environment that I wanted to be in.
Okay.
And so at 18, I became a teller for a large bank and have been in the industry ever since.
Oh, good. I know another guy that I work with, and he actually was in banking also, and he worked at a bank and was a teller. And he's very particular about the bills and things like that. So were you the same way also? And
Yes, always like the faces facing the same way. And
I can see, you know, the reason behind that, right? Because otherwise it's messy and things like that. But it seems like nowadays there aren't as many tellers because there's a lot of people that do things online, or they do an ATM, things like that. But I personally always, I'll tell you this right now, I always go into the credit union because I like dealing with people and the people behind the counter like that. So
yes, and we love to see you as well. But yeah, banking has changed quite a bit. So.
indeed, but thank you for still having that service available for me.
Absolutely.
All right, so how to start a business. So let's talk about what we're going to look at today.
Yeah, so it's, you know, one of the most common questions that we get is, you know, how to start a business and how to fund a business. And so, you know, a few principles that obviously we want to establish when you're thinking about starting a business is, you know, what is the purpose of it? What need does it fill? You know, what does your product or service do? You know, who's your target client and market? And of course, what are the action items that you need to take to make this happen? So one of those things is market research. So we all have to do our homework whenever we're gonna, you know, start a business. So one thing, you're gonna, you know, research your product and other replacements to your product or service. Again, the industry, market conditions, so the economic cycle is important to knowing, you know, when to start a business. You have to research your competitors. Barriers to entry are also important. You know, how easy or difficult is it to start this type of industry?
So Lucy, before you keep going, I'm going to stop you right there with the research, the barriers to entry, because you said that you mainly work with businesses that have been in business for a couple of years and are kind of already established. Are there instances where you've come across where they've been in business for a few years, but now there are barriers coming up and they have to modify to get into something else?
Yes, so, you know, as business climate changes, you know, they may have to adapt. Like, for example, when COVID happened, their product may become obsolete, or there may be a need for, you know, all of a sudden face masks or protection. Right. So, you know, they need financing to switch gears, if you will, to that new product or service. Gotcha. To meet the demand of the market conditions. Okay,
because I was going to say, a lot of times it's great if the way you started, everything keeps going smoothly, but it seems like there's going to be hiccups in the road every once in a while also.
Always, always. Yes, there's different stages in the growth of a business. As a credit union, we do open accounts for businesses that are brand new, and we're able to offer some small lending up to $25,000. So we are able to at least help get them on their feet. But again, for any of the larger lending that I specialize in, it would be a business that's 2 years and over.
All right, well, I'll let you keep going.
Also, it's important to determine, you know, the business structure that you're going to form. I always send my clients and refer them to their CPA and their attorney for guidance on this. Each different business will benefit for some of the pros and cons of the different business entities. Location, obviously, different states have, you know, more favorable regulations, so that could be important depending on what type of business you're starting as well. And again, the most popular question is, you know, how do I fund my business? It's going to be self-funding, you know, whether it's your 401k, your home equity loan, your personal savings. So you've got to have skin in the game in order to start that business. Or if you have, you know, a rich uncle, a family member, friends, investors, crowdfunding, that type of thing. And then there are some government grants and micro lending available, kind of like I mentioned, the $25,000. But depending on the type of business, if you need additional capital, those are the kind of
Well, it's nice you say you need to have a little skin in the game and a little family member and stuff like that. So there's always somebody willing and ready to lend you a helping hand, let's say, at different percentage rates.
Yes.
But we'll continue on.
Yep. Yep. And then marketing, of course, that's also an important decision that you have to research based on your business, product, or service, you know, whether it be social media or print, commercials, etc. And then finally, you know, you have to, you know, finally roll up your sleeves and design your prototypes, test your product or service. You know, that's where your friends and family, neighbors are going to come in handy, and, you know, get feedback from others. Again, do some financial projections and break-even analysis to see, you know, how your product's going to fare and pricing, et cetera. And then again, you brought that up earlier, but we've got to properly plan for growth. Sometimes businesses grow too fast and they run out of money, so that's one reason that businesses fail. And then form your leadership team and establish key roles. And again, these aren't exactly in chronological order. You're going to do these things as you go and form your business.
All right, nicely done. So come on back over here, Lucy. I've got some more questions for you now.
Sure.
So one thing you said was figure out how you're going to market the business, and you spoke a little bit about social media. Do you think it's possible for somebody to start a business, or even if they're established right now, a year or two, to be very successful without social media?
I think it's tough in today's environment. You know, that's one of the marketplaces that a lot of consumers, you know, go to and are on. So I think it's possible, but it's a
more challenging,
great,
I would imagine,
yes.
right? A little bit more difficult, because I was just thinking, let's say you're over 50, right? You probably didn't use as much social media as somebody that is 20 or 30 right now. So they would be more adept at it and things like that. So I would think that you might want to partner with somebody that could take care of that part to help the business grow. Does that make sense?
Absolutely, yes. And that kind of goes back to what I mentioned, is who's your target market or client. So again, depending on what your product or service is going to determine your marketing strategy that's going to be best, you know, reach your target client.
And what would you say if somebody wanted to start a business and I say, you know what, I want to sell whatever furniture it is that I'm making? Is there kind of a base where you go, you know, you need this amount of money to kind of start?
We don't have the expertise necessarily to provide that advice. So when I have a new business starting out, I'll often refer them to the SBDC.
Okay,
so
then they'll help them as far as the price, and then you help them as far as getting that to get started.
Yes, with the lending piece.
Nicely done. So you, I know you're with Kern Schools Federal Credit Union, and a lot of times people get pins. All right, Valley Strong Credit Union. Oh, I was thinking of Kern County Superintendent of Schools office. So we're mixing both of them. You know what, Bo? You guys have been partners with us for a long time, so it's like we're kind of together.
Yes,
anyway.
we're all in one.
So anyway, we want to say thank you for coming in, talking to us about starting a business right there, and just to do the math pin for you right there.
Thank you.
So when you put that on there, you can go around town and tell everybody that you're a star of the show now. You good with that?
I will. I'd be glad to. Thank you.
All right. Thank you, Lucy, for coming in. We'll be back with more right after this.
The tragedy of the commons is a dilemma that develops when a group shares a limited resource. Imagine some farmers are sharing a pasture for their cows. The cows eat the grass, but the grass grows back, and so the cows have plenty to eat. So they add more cows, which eat more grass. Eventually, the grass can barely grow fast enough to keep the cows fed. Farmer Alex decides to add another cow anyway. He figures the extra cow doesn't eat that much grass and will only mean a little less for everyone's cows, but he will get all the milk from the extra cow. Don't look at me. If I don't, they will. The other farmers feel the same way. Each knows that they are hurting the pasture they share, but their fear of losing out seems to force their hands. That's the tragedy of the commons. And it doesn't just threaten cartoon pastures. Stocks of Atlantic cod and bluefin tuna are greatly diminished. Aquifers that can replenish if water is withdrawn slowly are now emptying. Even roads can screech to a standstill while drivers wonder why others don't take public transit. By studying the interactions between people and their environments, researchers are becoming better able to figure out ways to protect ranges, forests, oceans, and even highways. This will become more and more important as the population of the Earth grows, but the space available stays the same. More people will be using the commons, and we may be on the brink of tragedy.
All right, in studio with us, we have Mikaella, a 6th grade student from Reagan Elementary. Feeling good still? All right, so you know a little bit about triangular numbers, square numbers, and pentagonal numbers. So I dare say, if you go into class tomorrow and you ask your instructor, your teacher, about pentagonal numbers, you'll be able to teach them a little something. Sound good? All right, you ready to do some more work? All right. Mick, how are you?
Good.
Doing well?
Yeah.
All right, head on
Good,
over to the
made it
board.
today.
Mikaella's
All right.
going to put you to work, all right?
All
So
right,
you guys
sounds
head
good.
over there. So I've got a math problem right here for you guys, so you're going to need to listen to what happened first, all right? So this is called the case of the museum mastermind. The Center City Museum has a problem. Someone has been replacing their artifacts with fakes. The museum director wants his artifacts back. The museum cameras have caught 4 people acting strangely. Who swapped the museum's materials, and how do you know? So, Mickey and Mikaella, what I need you to do is go through each person that was on camera and see what they did, and then see if there's any math that you can do to figure out who indeed swapped out the museum artifacts.
You ready? Because I'm not following most of that, so you're going to have to help me. All right, so I'm just trying to, so when it says Sam, is Sam saying this, or is this Sam is the guard?
No, this is Sam who they filmed.
Okay, and then the guard said 1,200 people came through the museum today. He said 1/4 noticed the problem right away. If 300 visitors could see it, then how could the curator not? So Sam is the curator.
So we want to know, are they telling the truth or not, Sam? And then we want to go to Alice and see if Alice is telling the truth. The same thing with Jed and the same thing with Betsy. We want to know, is this person telling the truth, or are they being a little shady and we need to see what's going on? So you're going to do each one separately.
All right, so if we have 1,200 people, and he said 1/4 noticed the problem. Well, what is 1/4 of 1,200? How do you think we could solve that?
Dividing.
Dividing? Okay, go for it. What do you want to divide by?
4 and 12.
Okay, go for it. Wherever you have some space, go ahead. 1,200 divided by 4. Perfect. And then if I wanted to add those other 2 powers of 10 back on, if we add those here, would they also go up top? Perfect. So does it match that that they're saying 300 visitors could see it? How could the rest have not known? Does the numbers match? 1/4 of 1,200 is 300. Yep. So it looks like Sam's telling the truth. Is that what we're working with there?
It looks like it so far. So
Okay. All right. I
Sam
just
is
want to make
left
sure
the
how
hook for
we're
them.
determining guilt here is by math. Just want to make sure we're getting there. All right. So do you want to go to Alice, Betsy, or Jed next?
Alice.
Alice. She seems pretty suspicious, right? All right. Well, tell me about Alice. We have someone said 1/8 of the 3,200 pieces of pottery were taken. It's a lot of pottery that was stolen. Where would I put the 800 pieces of pottery? Okay. So what do you think? 1/8 of 3,200. How could we solve that?
8 into 32.
Okay. Go for it. Perfect. And then if we wanted to add the 2 powers of 10 back on for the 2 zeros, where would they go? Yep, perfect. And let's just attach them to the 32 just for detail's sake, because it was 3,200. We'll just add the 2 there. Perfect. Now we got 400, but Alice said 800. So Alice seems a little shady, huh? So Alice's numbers aren't matching up, so she's a suspect, I would say. Suspect, yes? Is that how we're working this?
Indeed.
Bam, there it is. All right, so Alice, a little, I don't know, a little questionable, huh? All right, you want to go now to Betsy or Jed?
Betsy.
Betsy, another suspicious person. All right. The woman at the door said 2/3 of today's 1,200 visitors came by bus. I bet those 800 people had plenty of room on the bus to hide things. How would you solve it?
3 divided by 12.
Anything with the 2? The other ones didn't have a 2, did they? They all had 1s. So you think that's going to play into how we solve it? It is. So let's start with the dividing by 3 first. So go ahead and do 12 divided by 3 like you've been doing. Then we'll add our zeros back on for our powers of 10. Perfect. All right. Now the difference here is we have a 2 on top, right? So if I were to write this out, 1,200 over 1 times 2/3, because when I see the word of, it makes me think of multiplying most of the time. So when I have 12 on top and 3 down below, it's like saying 1,200 divided by 3, just like you did. The other part we have to do is multiply by the 2 on top. So let's take this 400 and multiply by 2 and tell me what you get. All right, does the 800 match the one that Betsy talked about? All right, so Betsy looks like she's good. Betsy's pretty clear. Sam's good. Alice is super sus. Let's go on to Jed. All right, so now we have Jed. Did you say 1/12 of the 3,600 exhibits were changed? If there were 300 swaps made, how come the director didn't notice until today? What do you think?
12 divided by 36.
Okay, go for it. Perfect, and then our powers of 10, our 2 zeros back on. Perfect, I love it. Does it match? It does, so it looks like Jed's good too. So who do we think is the guilty person?
Alice.
Mike, is Alice guilty?
I would say that Alice.
Yeah, Alice is going down.
All right, nicely done. So come on over here. I don't know about Alice going. Alice is going to simply replace the museum artifact. So come on over here.
I don't know,
guys.
man, that's theft. That's breaking the law. I don't know. Alice just gets to return it. I don't know what's going on here.
Well, we're going to say that Alice is going to, in the kindness of her heart, make sure that everybody is able to enjoy these, bring them back, and everything's going to be cool after that.
All right,
So-
sounds good. You're the boss. We'll let Alice come back. Sounds good.
So Mikaella, you had the opportunity to go to Camp Keep, and that was an exciting part of 6th grade. Is there anything that you think you're going to miss before you go to junior high school? Because you're going to go to a new school next year, right? So how long have you been at Reagan, as a matter of fact?
I think around 6 years.
Okay, so you've been there basically all the time you've been going to school. So is there anything you think you're going to miss about Reagan before you go to whatever junior high you're going to?
Probably like the staff there.
Okay, so that's good that you get along with the staff and you like the staff, right? Do you like this staff? Good. Well, I'm going to make you go do some more work. All right, so over to the board.
Come on, Mikaella.
All right, so
You work
Mickey,
with
I
the
need you to
best
put up on the board 94 and circle it. Underneath the 94, I want you to write these numbers with a comma in between them. 1, 2,
Okay.
4, 5, 10, and 25. So you and Mikaella can use any of those numbers. You don't have to use all of them. You're going to take those numbers and add, subtract, multiply, or divide to get 94. And I'm going to give you 3 minutes to do it.
You ready? All right, talk to me. What do you want to do? What do you think? Get 94.
I feel like I'll start multiplying 10 and 5.
Okay, go for it. So if you just want to start it here and we can PEMDAS our way through it, however you want to do it. And then I'll keep track over here. So we've used the 10, we've used the 5. So that gets us to 50. What are you thinking next?
Maybe like, then multiply 2.
Okay. So we're saying 2 times what? Oh, take this and multiply. Okay, so now we're getting to what, 100 here? Okay, sounds good. So now we're at 100, but now we have to go down to 94. So we're going to have to either divide or subtract to reduce. What are your thoughts?
Minus
Okay.
25.
Minus 25, that'll get us to 75. Okay, so now we're at 7. I keep tracking. We're at 75. So we need to go back up to 94 now. We still have a 1, a 4,
And that's it.
and that's it.
So here's one thing I would suggest you guys do. Instead of going up to get there, How can you quickly get to 100, first of all, by multiplying two numbers? What two numbers there can you multiply to get to 100?
25 and
25
Four.
and 4. Yeah.
All right, so start there.
That doesn't work the same way anymore. Man, the bigger. That ain't it. But that's the fist. That's right. I'm sorry.
There you go.
New board, new rules. All right.
All right, so go 25 times 4.
25 times 4. We'll start with that.
So now you're at 100, and now work your way back a little bit.
Now we're up to 100. Can we work our way down to 94 now? We got to get rid of 6 somehow.
To minus.
We're going to keep it as one function first. Okay.
5 plus 1.
Ooh, okay. So if I'm following PEMDAS right, so I have to multiply first. Okay, so that'll get me 100. I'm liking it. Now, do I get to subtract next, or do I have to add next?
Add.
And we're going to add because you put it inside of
Parentheses.
parentheses. So then I have a 6 here, and then what was the symbol in between?
Minus.
So we get to put it back in. And will 100 minus 6 give us the goal of 94? All right, there we go. Bam, that's how we do
Nicely
it.
done. See, so there are other ways to do it. So you could have worked your way up, or you could have gone a lot higher and worked your way back, but you did indeed get 94. So nicely done.
right.
And we'll be back with more right after this.
Our moon isn't the only moon. No matter where you are on Earth, you can usually look up into the night sky and see the moon. Our moon appears so big and bright because it's closer to Earth than any other planet or moon. But our moon isn't the only moon out there. That's right. In fact, some planets have a lot of moons. A moon is a natural object that orbits anything larger than itself. Moons come in many shapes and sizes. Our solar system has 8 planets and dozens of moons. Almost every planet has them. Mercury and Venus, the 2 planets closest to the Sun, have no moons at all. Earth, on the other hand, has one rocky and rather large moon. It's about 1/4 the size of Earth. Our moon is the only other place in our solar system where humans have set foot. What are some of the other interesting moons we know about? Well, Mars has 2 moons named Phobos and Deimos. They're dark and lumpy and at least 100 times smaller than Earth's moon. Jupiter has more than 70 moons. Several of them have very unusual features. For example, Ganymede is the largest known moon in our solar system. You can actually see it from Earth with just a pair of binoculars. Jupiter's moon Io is covered in volcanoes, and there's thought to be a giant saltwater ocean under the icy surface of Jupiter's moon Europa. NASA is planning a future mission to investigate Europa and its underground ocean. Saturn has more than 80 moons in total, and at least 2 of those are ocean moons too. They are called Titan and Enceladus. NASA's Cassini mission discovered that the underground ocean on Enceladus shoots jets of icy particles from cracks in the moon's surface and out into space. Uranus has more than 20 moons. Its larger moons, like this one named Ariel, are thought to be made up of half water ice and half rock. Scientists have discovered more than a dozen moons orbiting Neptune. Its largest moon, called Triton, has volcanoes with icy lava flows. Brr! Volcanoes, underground oceans, and icy jets? What do you think we'll discover on moons next? Find out more about moons at NASA Space Place.
A fraction.
All right,
Really?
already getting to work
A
are
division
Mikaella and
problem.
Mickey, and right now they're working on fractions and
3
decimals.
divided by
So, Mick, what do you guys have going on right? You're talking about place value first?
Yeah, so we reviewed the names of the place values behind the decimals. So the first place value behind the decimal is the tenths, the second one is the hundredths, and then we talked about really quickly, if I said I had 1/10, then Mikaella drew out in fraction form, it would be 1/10. The 10 corresponds with the name of the place value. So same thing, what if we had 12 hundredths? Mikaella, how would I put 12 hundredths into a fraction form? What would that look like?
It's like 12.
12, and then it ends in the hundredths, so it'll be over hundredths. So 12 over what? What do you think?
100.
Go for it. Write it down. Let's see. Perfect. Yep, so wherever the number ends tells me what number really has to go on the bottom. So if it ends in the tenths, like you had in the 1, it goes over 10. If it ends in the hundredths, it goes over
100.
100. What if it was the thousands or 10,000s? We would put those numbers, okay? But now the question becomes, well, what if my fraction, right? Because this 10 could tell me, oh, it goes in the tenths, the 100 goes in the hundredths, but I don't have a fourths place. That doesn't exist, does it? So what's our strategy? I know we worked one out already, but walk us through what you, oh Lord, that's interesting. There we go. All right, so walk us through, if you had 3/4, how would that become a decimal? What's the strategy we could use? Because I can't really make 4 into a 10 or a 100 really easily sometimes. What's a strategy students could use to change any fraction into a decimal?
I can like divide the
Okay.
denominator by numerator.
Divide denominator by numerator? Go for it.
Yeah.
Yeah, goes in 0 times. Nice. 4 into 30. 7. We're rocking and rolling. I'm loving it. Left with 2. No, the 0. Good choice. 20. 4 into 20. Yeah, now we're cooking. And nothing left. So we notice, even if we have a denominator that's not as easy to work with in the tenths or hundreds or thousands, if I want to get a decimal, any fraction can be turned into a division problem. Even if, let's say I have 22/67. These numbers aren't really compatible with tens or hundreds or thousands, right? But can I still divide to get a decimal? No matter what, no matter how crazy the fraction looks, we can always take a fraction and turn it into a decimal. There's one more trick I want to give you. Whether or not your teachers told you about it, I don't know, but I want to give it to you. So if I have 1 and 3/4, you already told me that 3/4 really becomes 0.75. Do you agree with that? What do you think the whole number 1 is going to do? Because that's not in this problem. How would that play into this final answer, you think?
By adding the number 1 before the decimal.
Man, I got nothing by you. You're on it. I love it. Yeah. The whole number 1 goes on the whole number side of the decimal, which a lot of students are like, I don't know where the 1 goes. It's magical and it disappears. And I'm like, no, it can't disappear. So you're right. It is a whole number 1, so it stays on the whole number side of the decimal. You're rocking it. I'm loving it. Mike, do you have a trick for us? Any special challenge problem you're thinking of with fractions and decimals that you want to throw at us? What you got?
No, what I'd like you to do is take the 3/4 and now move on to some equivalent fractions.
Oh, okay.
And we'll
ready?
do that, and then we'll maybe hit percent a little bit. But we've got 3/4, and we'll do some equivalent fractions with that.
Okay, so let's clear the board with our, no, wrong one. There we go. All right, let's make some room here. Use your side of your hand. Let's erase some space here. So go ahead and take off your division problem. So we can get this to erase. We're getting there. Nope, I don't want to erase anyway. It's kind of erasing. Oh, it's because she's erasing. All right, you're the eraser queen. Go for it. Take it away. Take it away for me, Mikaella. There we go. All right, once you have that one done, we'll work on 3/4. All right, perfect. Thank you. So now we're working with 3/4. So we have 3/4 here. How can we take 3/4 and turn it into equivalent ratios or fractions? Because really this is also a ratio or a fraction. What do you think we could do to make equivalent ones?
Like, I don't get it.
I got you. So let's say, you like candy bars? You got a favorite one? All right, I'm a Twix guy. I love a good, Twix bar. It's kind of, I didn't really like candy. I tried a Twix and I was like, this is cool. All right, so the 4 in the denominator tells me I have 4 equal sized pieces. Now I don't know about you, that's pretty close for freehanding it here. Now the 3 in the numerator tells me 3 of these are filled in. Does this look familiar to you? Okay. The question is, if I have a candy bar and I cut it into a different number of pieces, how many of those would have to be filled in to have the same amount? So if I took it and I split it into, let's say 8. 1, 2, 3, 4, 5, 6, 7. Not as pretty, but I think we get the idea. How many of these would have to be filled in to have the same amount? Let's see. 1, 2, 3, 4, 5, 6. Not perfect, but pretty close, right? Is there a way, this was 8 in total, and I filled in how many to be equivalent?
6.
Do you see a relationship between the 6 and the 8 and the 3 and the 4.
Yeah.
What do you see?
Multiply the numerator and denominator by 2.
Yes. So it has equivalent BI factor of 2. If I double the number of pieces I make, I also have to double the number of pieces I shade in. What if we doubled it again? Do you think it would work? Go for it. Double it and we'll see what we get.
There you go. Nicely
Exactly.
done.
So if we were to
you
take that
guys
candy bar and cut
submit-
it into 16 pieces, we would have to shade 12 of them in to get the same amount.
I'm going
Mike?
to stop you there. So come on over
All
here.
right, let's head on over.
So come on over. So you guys worked on fractions, decimals, equivalent fractions, triangular numbers, square numbers, pentagonal numbers, trying to figure out who was lying based on the number of fractions and the number of pieces. So you've done quite a bit of business today, right? All right, good. So you are now an ambassador for Do the Math. You know what that means? That means all you have to do is simply tell people about Do the Math. Can you do that? All right, good. You know what? There's some things that were going on over the weekend. One was Via Arte, brought to you by the Bakersfield Museum of Art, and that was held at the Marketplace this last weekend. And there were 2 that were awarded the People's Choice in the high school, and here's one of them right here. And we were looking at jellies before, and it just so happens to be that one of them is right there. This is all done by hand with chalk on the pavement of the Marketplace, and just simply spectacular. And we have Bakersfield Christian High School and Highland High School being awarded the People's Choice Awards for the high schools, and just simply magnificent. And the Via Arte program that the Bakersfield Museum of Art presents with us every year is just fantastic. I know that they've been in studio working with the kids as far as scaling down something and being able to look at that. And then we've got one more. Mickey was featured in the Bakersfield Californian in the news as one of the 20 under 40, which I guess, Mick, means you're one of the 20 hotshots under 40 years old.
Yeah, you all forget I'm under 40, all right? So just be gentle on that.
All right. So quite an honor for you.
Yeah, it's something I never thought I'd be a part of, but to be considered, nominated, and then accepted as one of the 20, it's a very proud accomplishment for myself. Yeah.
And you know what? It's nice to know that you have been part of Do the Math for how long now? Think about when you first started coming here.
Oh man, when you brought us here as kids, is that what we're talking about?
Right, so you came in as
20 years
kids.
ago? It's been about 20 years. I mean,
Right, so
I've
this
been an
is the
employee for
23rd
like
year of
8
Do the
years.
Math, and you've been part of Do the Math for about 20 years coming. And the same with one of our producers, Mackenzie. She's been part of Do the Math for a long time also. So anyway, we at Do the Math just wanted to say congratulations to you on that. Quite an achievement. Mickey is one of the 20 under 40. Don't forget, anything going on at the Museum of Art, you want to go check that out. You can always check out their website, bmoa.org. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.